call him Sanders.
You call him like Jesus Sanders.
I don't think he had straps like that.
Are those furry ones?
Yeah.
Did you try to take the square root first and see if it's a whole number?
Yeah.
Is it? 8 squared 64. 9 squared is 81. It's between 8 and 9, but that's not what it asked us for. Simplest radical form. Who's confident in their answer? Luca. What did you break 72 into?
4 and 18.
The square root of 4 times 18. Then what?
4. The square root of 4 is 2.
So you went right away. You said the square root of 4 is 2 times the square root of 18. Yes?
Yeah.
Did you go any further?
No.
You stop there? Now, shouldn't we check to see if this can be simplified at all, though? What is the square root of 18 break down into? Luca.
What times what's 18?
9 and 9 and 2. Then you should ask yourself, is 9 a perfect square? What is it? So 2 now has a little friend. What's its friend? A 3. And what is lonely inside all by itself? 9. No names. No names. It's offensive. What's inside all by itself? 2. Last step is to multiply that 2 times 3, and we get 6 times the square root of 2. So, Luca, yours was a simpler form, but it wasn't the simplest radical form. Make sense? Keep going. Let's make a little rule. How do we know when to stop breaking this number down? How do we know when to stop breaking this number down?
It can't be broken into 2.
What's that called? Prime.
Optimist.
Call me Mr. Prime.
That's cool, right?
Mr.
Is 2 times 2 times 2 times 3 times 3 72? Yeah. Now, if you're this person right here, look at me. If you're this person right here, if you don't like to say, okay, the square root of 9 is 3, if you like to keep going and say 3 times 3, it's fine. What are you going to do now once you break it down into all of its primes? What's a 2 times a 2?
2 squared.
Good. And the square root of 2 squared is? 2. Yay, it gets to come out. Ready? 2. Does it have a nice partner to make a square?
No.
I'm sorry, it has to stay. How about 3 and 3?
3 squared.
3 squared. Square root of 3 squared comes out as a 3. What's left inside all by itself?
2.
And you could say 6 times the square root of 2. So if you like to break it up into all of its primes and then find the pairs that make squares, that rhymes. You could do that.
McDonough, what's up?
Could anyone answer me 3 times the square root of 8?
Yeah, but 8 is 4 times 2, and 4 is a nice square root. It's got a perfect square. It could come out as another 2. You said this?
Yeah.
Yes. However, it's not just like Luca, it's not the simplest radical form. Isn't 8 4 times 2? And isn't the square root of 4 another 2 that gets to come out? Right? So just keep going.
Okay.
So you guys are probably going to need to, like, you haven't learned the process well enough yet to start recognizing those. You probably need to go down to all the primes. Make sense?
It's like reducing fractions, McDonough. You didn't put it in its lowest terms, that answer you gave, okay?
Got some work to do here. What are you confused about?
I don't know what to do. Maybe just for this part.
Guys, Look at 75.
Would you just pick the two there?
What goes into 75, guys? Big number. What goes into 75? Think of money.
3 and 25.
25, right? So I know 25 is going to break it down that way.
What?
Start with that. 25 times what? What do we got? How much? 25 times what, guys?
27.
Okay. Now, keep breaking it down. Keep going down. Right? What about this? 3 times 9. So I'm going to circle my primes as I go. What's 3 times or 9? Go break down to. Bless you. Okay, guys, look. Okay. Now, don't forget about that too. Okay, I have 3 3s. 1, 2, 3. And how many 5s? 2. Okay, is everybody okay with how we got there? Right? Okay. Do I have a pair of 3s?
Yes.
So, as Mr. Westphal said, that's 3 squared. How many can come out?
2.
No.
What's the square root of 3 squared?
Only if I have a pair, 1 comes out.
Oh, yeah.
That's all I can take out. So 1 comes out. So I have a 2 was already out there. So 3 times 3. That's gone. What stays? The 3 stays. Okay? That stays. Do I have a pair of 5s?
Yeah.
So 5 squared. What's the square root of 5 squared?
5.
Nothing stays. So what's 2 times 3?
6.
6.
Times 5.
30.
Get a Michael man.
What is Michael gonna do?
Bailey, can you hear me up there?
And
Tap twice if you understand. That's terrible.
I miss Bailey.
I do miss Bailey.
he looks at the ground.
Coincidence.
It's high, right?
All right.
It's so mean.
Now we have to do this.
And 1 more.
There could be variables inside the radical.
What?
Okay, guys, this is easier. Okay, guys, what's the square root of x squared?
X.
Yeah, think of it like this, because this is the same thing, right? I have a pair of x's. How many can come out?
X's.
Okay, 1 can come out. Now,
Ooh.
x cubed is 3x's under the radical. How many pairs do I have? Think of it like this if you want to. Think of x cubed like this. Right? We just did x squared. What's the square root of x squared? X. I have a pair. 1 can come out. Like we did here. 1 can come out, but what stays, guys? X square root of x. Okay? X square root of x. How about x to the 4th? How many x's do I have? All my x's live in the radical. There's 4 x's. How many pairs do I have?
2.
Those.
So how many can come out?
2.
What's my answer?
X squared.
X squared. Is there anything left over?
Uh-huh.
No. It just simply goes to that. Okay, what do you guys think about this? It's really x to the 4th times x, right?
Yeah.
Well, we already know what x to the 4th is. I can take what? 2 out. Is there 1 left over? Yeah. Do you guys see the pattern?
Nope.
See the pattern there? Is there another one? Yeah. What's this one?
X cubed.
Yeah, guys. X cubed. So somebody tell me the pattern. What can I do? Think of it this way. Anybody see it? Go ahead, Zach.
You take the square and divide by 2.
Well, you take the exponent and do what with it? Cut it in
2.
half. Cut it in 2. That's my answer. Because think about it, guys. If I have, guys, look up here. Pay attention. If I have x to the 6, do you guys agree it's 6 x's? So how many pairs do I have?
Trust.
X cubed. If it's an even number, there's not going to be anything left over. Exponent, right? With a variable. But if it's odd, I'm always going to have one left over.
So there's 12.
Okay, so let's look at this right here. Write this down next to there somewhere. Let's do this. Okay? Let's do it mentally. Okay. Do I want to write 21 x's down?
No.
No. Guys, take it down. I know I'm going to have one left over. Right? Take it down 1. What's 21 minus 1?
20.
What's half of 20?
10.
Okay, let's do one more. Let's do this. Okay. Now it's an odd number, right? I know I'm going to have one in there. Take it down to a Hondo, right? 100. What's half of 100?
50.
X to the 50th times, or radical x, or square root of x. All right, let's try this one now.
Oh,
It's not hard.
Oh no.
Put what we learned. We have 300. Guys, what's half of 4?
2.
So I have what?
X squared.
X squared. What's half of 8?
4.
I can, right? I know I'm going to have what? I know I'm going to have a z in because it's an odd number. Take it down to squared. What's half of 2?
1.
I have a z. Z to the first.
That was easy.
Don't say easy, please, around Corbin. He gets upset.
That was hard.
Okay, does everybody understand the pattern there? Okay, now, as you can guess, we're going to have numbers and variables.
Uh-oh.
Okay? I always like to deal with the number first. Guys, I like doing squares. What's the biggest perfect square that goes in the 50? Look at your perfect squares. Flip it over. What is it? 25 times what? 2. Does everybody agree? 25 times 2 is 50?
Yeah.
What's the square root of 25? 5. Right? I'm taking 5 out. What's left under? 2. Everybody with me? X squared, what can I take out?
X.
1. Is there anything left over x-wise? Nope. It's an even number. Even power. What about y to the third? Y squared times y, which is, I can take a y out. Very good. What's left over? You know there's going to be a y in there because it's an odd power. That is my answer. That is my answer. Oh my. Or you can do the reverse of this. Guys, look. Hold up. Hold up. I got even. Take care of your variables right away. What's half of 4? What's half of 2? I'm done with this. Okay, you can do it that way. Now I got to do what? Okay, you guys handle 160. Handle 160. Doesn't matter how we start as long as we finish on the same page. I'm going to do 16 times 10. Ooh, 16 times 10. For the grace of goodness. That's a perfect square. But we'll keep going. 2 times 8. 2 times 4. 2 times 2. What's 10? Break down to 2 and 5. How many 2's do I have? Or I? 1, 2, 3, 4, 5, and or 5 of them, and then a 5. How many pairs do I have? 1, 2 pairs. So that means 2 comes out. 2 2's, right? Okay, so I got 2 2's outside. Takes care of those. What's under? The 2 and the what? 2 times 5. So it's 4. What's under the radical? 2 times 5, which is? Okay, what do I have to apply now? 4. You always put the 4 in front of the variables. And then what's underneath the square root? 10. Guys, right here, right? You could have done, square root of 16 is 4. Square root of 10 or 10 can't be broken down into a there's no square root that goes into 10. I could have went right there to 4 radical 10. If you guys see that. And that's your answer. I think that's it.
Well, there's one more.
Oh, there's one more.
Yay.
Do we have to do one more?
You still good?
You guys feel good? Or you want to do this one?
Do it.
No.
There's a worksheet for homework, right?
There is.
I'll pass
It's,
that on. So if you guys want to get started on the worksheet, you don't need another problem. Go for it. It's gonna be for homework. If you want to see this one worked out, we can do that too.
Guys, let's take care of our variables. What comes out of x squared? Can I do anything with the y? Okay, so this will be my answer right here. X comes out, y stays under. Okay, I know I'm going to have 5 times something, so I'm going to bring that down. So now we got to work with 504. Guys, start dividing. What goes into 504 besides 2? Try some numbers. 12 and what? 42. Thank you. Again, you didn't have to start with that. I know 12 is 4 times 3. 3's prime, and I got 2 times 2. So I got 2 times 2 times 3. 42, what is that? What goes into 42? 6 and 7. 6 and 7. 7's prime. 6 is 2 times 3. Okay, so let's write it down. How many 2's do I have? 3? 1, 2, 3. And I have a 2 3's and a 7. That's all under square root symbol still. Okay? All right, how many pairs of 2's do I have? Okay, that comes out. 1, 2 stays under. Do I have a pair of 3's?
Yeah.
1 comes out. Okay, 2 went there. Those are done. Those are done. 7 stays under. I only have 1 of them. So what is it? 6 radical what? 6 square root of 14. And then you have to apply it to what we already did with our variables. So it's going to be what? 6x times square root of what? 14y. What's that? Oh, thank you. Thank you. I forgot that. 5 times 6 is what? 30. Don't forget to do that, which I just did. 30x times 14y.
Hey guys, one of the main things to remember, it's going to trip some people up. That number inside, doesn't 14 look like it could be it could be broken down more. But because it's an even number, it bothers people. It's like, that doesn't look right. But what's the test? Does 14 have any
the numbers that multiply.
what do we call pairs, right? Are its factors, do they make any pairs? What are 14's factors? 7 and 2. Are there any pairs there? No, so that's simplified. All right. Check the number that's still inside. See if it can be broken down and make any pairs. Doesn't have to be a prime number under there. Just can't have any pairs.
What's that? The only number it goes into is itself in 1. Like 11. 1 times 11. 11 is prime.
Floating around the yard with magnified.
You know, the first prime number
2 is 1 times 1.
is 2 times 1.
No.